Hello everybody, Thy Lord Root here, and today we will be taking a look at the Unity game engine. Most everybody is familiar with this largely because of the games that have come out. The Kerbal Space Program is one, of course, that springs to mind. And there are plenty of tutorials for this, but I wanted to redo one that is an official tutorial because, well, for one reason it was done back before 4.6 and some things have changed about that. And also, just to have a different perspective from a different kind of programmer as well. So I'm going to call this ball game, and the idea is that we're going to be rolling a sphere around and collecting these items, and that'll be it. So we don't want any packages here or anything like that. We just want to go ahead and create this guy here. So my screen will probably be a little bit different than yours because I've rearranged everything. You can move these guys around as you wish. They're tearaway tabs, so you can put them wherever you want. I just happen to like it this way because the default layout is not quite as good in my opinion. So first thing we should do is create a folder at our project listing. We will call this Scenes. And second thing we should do shortly thereafter is hit Control S to save. Go to Scenes, we'll call this Level 1. What is a scene anyway? Well, a scene is basically a place where, you can display meshes and everything. It's where action takes place. So think of a scene kind of like on stage for a play. Think of it that way. Now in this case, Unity uses something called the scene graph metaphor, and the idea is that we can create objects here, and let me just create a few. I'm starting out with the sphere just because our character incidentally will happen to be this way. And we've got these transformations here, so I'm on the capsule right now, and I'm just going to reduce this to 0.5 in the X direction and 0.5 in scale. Now this is a child of the sphere, but if we move the sphere up, then the capsule will move along with it. This transformation here is relative to the sphere. You can imagine how that might be useful. I'm just going to delete that for now because we don't really need it. And I'm going to return this back to 0. Now incidentally, because we're rolling a ball around in our game, I'm going to rename this to player by clicking on it and typing in player. You can also go to the inspector here and change its name that way. I'm also going to add a tag to this, which I will explain shortly, but for now let's also tag it as player. So far we do not have much of a game here. We have a grayish sort of circle in the center of the screen that doesn't do anything. That's not really what we want. So let's go by and see what we can do here. First of all, let's look at the sort of model that this uses. This uses something called the model view controller pattern. And the idea with model view controller is that you have your model, that's the actual sphere itself. And then you also have the view, which is the mesh renderer. And on top of that, rather, you have the material under that. And then you also have the controller, which are these scripts, one or more scripts that you can attach to it, or 0 if you'd like. You don't have to have controllers on there. If you're more interested in that sort of thing, Kay Horstman has a book on object-oriented design. It's fairly popular at universities. You can also read about it on Wikipedia. But for right now, we're just going to stick with this. What can we do to this sphere to get some action out of it? Well, of course, we want to be able to move it around, and one of the things we can do is we can click on Add Component, then this Physics menu, and rigid body. Rigid body makes this thing physical. So we have a collider here, which means that things can bump into it. And in fact, we have a sphere collider, which basically uses the Pythagorean theorem. And if you know your trigonometry, you know that as you increase the angle, if you keep the hypotenuse the same, then you can keep your radius constant. So that is one thing that we can do here. But I will be right back. Sorry about that. We're back now, and what we will do is, I guess, we'll continue this discussion. But adding this rigid body actually makes the sky physical. So you can see we have used gravity here, we have mass, we have angular drag and drag. So what we can do now is if we hit play, this guy will fall. As it turns out, light would be better to have, so this is where the power of the scene graph comes in. We can create an empty node here, and we will call this lights, which in and of itself does nothing. However, if we now go to light, we can select different kinds of lights, and in our case we want a directional light. Now, the only thing that really matters about a directional light is the direction it's pointing, and so you don't have to worry too much about its position. In fact, we can go up here and move this out of the way slightly, maybe 4 or so, and our lighting does not change. However, it might be good for us to look at this and get some idea where we want our light to go. Now, one way we can do this is we can go to the scene view, and we can hit this rotator here and rotate the sky around until we're happy. And so here we have a fairly decent light going on. We're going to call this the main light, and we're going to leave it white. I'm also going to add a shadow to it. There's hard and soft shadows. For now, hard shadows are good enough, but soft shadows can look better at the expense of CPU power. Typically, you have another light called a fill light that fills in the dark areas, because this behaves just like a light would in space. So for here, we're going to go around down here and have this guy pointing up just a little bit. I'm going to go back to this guy here. It almost looks like a marble this way. And it helps with our fill light if we change the color. So I'm going to change it to this bluish color here, and I'm just going to rotate this until these shadows are filled in. If we look at our game view now, we're more or less taken care of. Now I'm going to create a floor for the level by creating a plane. And there's something worth pointing out here. 2 things, actually. The first is that we are in the center of the plane, and we can tell the size of the plane because each one of these units is one unity unit. I am simply going to drop unity unit because it's kind of superfluous. It's completely arbitrary, so I'm just going to say 1 instead of 1 unity unit, or 2, and so on. Anyway, this sphere has a radius of 1 unity unit, and so what we can do is or rather its diameter is 1 unit, so we can calculate the radius as half that diameter, and we can simply move either this guy down by 0.5, or more likely we'll want to move the player up by 0.5, and that's going to leave a bit of a question. What are the directions of the axes? Well, up and down is Y, Z is back and forward, and in this case we find that X is left and right. So we are pointing on the opposite side of the camera now. Let's just go over here to the opposite side to where we're facing the back, where the camera is. And let's find our Y. Move this guy up to 0.5. Now, at this point, because there's no physics on the plane, we are not falling through, but we can't move around because we haven't told this thing how to be able to move around yet. So what I'm going to do is I'm going to create a folder called scripts, and we're going to attach a script to this sphere. Now there's 3 different languages we can use for this. I haven't looked to see if you can possibly add plugins for other languages, but you have C#, .NET, and Boo. I'm going to call this player controller and make it a C# script. So we'll add this guy in here. And let's look at getting, first of all, we'll want to move this script here, and then we'll want to open MonoDevelop, and that will help us a great deal here. So we've got really a few things we can talk about here. .NET and, well, C# in particular is object-oriented. And so in an object-oriented language, you have classes which are sort of like blueprints for objects. And objects have states and behaviors. Those of you who have programmed in procedural languages like C probably recognize this as a function. Technically, it's better off called as a method, and that's what object-oriented folks like to call it. But those are behaviors on the object. And then we also have the object state, which translates to its fields or variables. So there are certain special methods that get called at various points in the player controller, and because of the way probably that MonoBehavior is set up, this guy has several things it can do. We're going to look at a very special method here called fixed update that happens before rendering but after update. And in particular, update is called before the rendering. This start callback here is called, I believe, when the scene is initialized. And we're going to create 2 variables here. We're going to create a variable for a horizontal movement, and in order to grab that, we'll say input get axis horizontal, as the horizontal will be a string literal here. Note that these guys are of course case sensitive, and so like this wouldn't work. But also the name and the string, just because of the way that I guess the axis mapping is set up, is also case sensitive. Let's do a similar thing for our vertical as well. And so once we do that, we need to next talk about vectors. And so those of you who have taken physics may be familiar with what a vector is. For those of you who aren't, the vectors that you're most likely to run into, and the ones that in particular are most important here, are rectangular vectors. So a vector is either a magnitude and a direction in this case, and that's in polar form, or it's a collection of component scalars, a scalar being just like a number, just an individual element that you could multiply the vector by. And so, as an example, the Cartesian coordinate plane, which you graph on, you might notice that like a point has two numbers. That point is a vector of two numbers. Another thing about float here, the reason I'm using float is because this could be a real number. Now, it's worth mentioning that if you've taken computer architecture, you know that there are certain limits on floating point numbers, especially IEEE 754 numbers, which are most common. And that tends to be that, first of all, you have gaps in your number line. Other than that, you also have a minimum resolution as well. So these floating point numbers are actually somewhat discrete in a way. They're not continuous, even though to regular maths they might as well be. Anyway, let's create ourselves a vector here. Say vector3 movement is equal to new vector3. We know which direction, if we want to go side to side, we want our horizontal direction in the x-axis, but what about in the y-axis? Well, remember that your y-axis makes you go up and down, and so we want 0 there. And then finally, we want our z to be our vertical here. Now there's two ways we can approach this. You might think, well, velocity is... In fact, we'll just call this velocity instead. Velocity is change in position over time, and if you've taken calculus, you know that it is the first derivative of position with respect to time. So you might be tempted to do something kind of like this. We can take our rigid body, and then we can grab the transformation matrix out of there, and we can get position. We could say position plus equals velocity. And when we do this, we get a very quick thing going on here. Well, that sort of works. It's hardly controllable. So instead what we might do is we might say rigid body dot velocity is equal to velocity. And this does slow us down a little bit. It allows, you know, instead of us moving 1 unit per frame, it allows us to move at 1 frame or 1 unit per second, which incidentally is quite slow. So we do not want to do that. What we can do, however, is we can create a variable called speed, and we're going to create a public field for this. So public float speed is equal to, I don't know, 5 is good. We can even say 5.0 f. When you're working with floating point numbers, you do want to add that f on the end, because if you don't, then it thinks it's a double precision number, and .NET does not like that. So, two things we can do here. We can either multiply this by speed, all of the components individually, and that'll work. Or we can do scalar vector multiplication, in which we have the scalar value speed, and we multiply it by the vector. And that works pretty well. And so if we try this, now we have a reasonable movement going on, and that is cool. In most games, you don't want the player to move out of the camera, and so I will be back just momentarily again. So we are back, at least I think we are. I guess we need to check OBS real quick and see. Yeah, we are definitely back. So yeah, anyway, about the camera, usually the camera follows the player, and we can just drag the camera under the hierarchy, and at first you might think that this would do the job. except that our ball rolls around, and because the transform of the camera is relative to that of the player, then the camera rolls around too. So that is not good. Instead, what we want to do here is to go to the player. If we go to that rigid body, you'll see constraints. Expand that and freeze rotation in all those guys. And now we can move around like so. Now I want to move the camera up a little bit. 3 is probably an okay height for us, so that we can see, maybe even 2.5, because we're going to put walls on this thing. So I'm going to rename the plane to level, and let's add in some walls. We can go to this cube here. I'm going to set the height to 0.5, and let's make the scale. Well, let's think about this. We're pointing directly from the back right now, so what we want to do is we want to make this extend in the X direction for the northern wall, so that it covers the entire thing. So we have the north wall here, and we will push this in to 5. Now we could recreate this, but it's better to duplicate it, and we'll make the south wall now, and all we have to do is negate that. Finally, we'll just create a new cube for the second wall. We'll call this the west wall. That'll have an X of 0 and a Z of 0. Actually, the X should be 1 here, otherwise it'll make it flat. And then we'll make the Z 10. We'll move this to the -5 in Z, and then when we duplicate this to make our east wall, we will set this to 5. And now we can roll around the course as we wish. Now, it may be a good idea to go back to this player, and let's just see what happens if we unconstrain various parts of this camera. Well, if we roll around, we don't want to rotate over the X for sure. What about Y? Well, Y seems to be okay. It's not really doing anything for us. And if we do Z, Z is not doing well as well. So yeah, we'll leave those all unconstrained for now. Incidentally, any changes you make in play mode will get reverted once you are done, or once you unplay it. So yeah, I guess now maybe the next thing we want to think about are how we can put collectible items in there. So I'm going to create a cube here, and it's off center, so what I'm going to do is I'm going to go up to this gear in the transform in the inspector and hit reset. And for now I want to, you know what, I'll move this up 10 real quick just to prove a point. We can add we can add gravity to this if we want by adding a rigid body, and in fact we should add a rigid body to it. But watch what happens when we put this rigid body on here. Now our player has a hat, which is not really what usually you want pickups to be destroyed, right? So I'm going to go ahead and disable the player real quick, just so that we can have a look at this. I'm going to set this to 0.5 for the height, and then we want this thing to be somewhat smaller than the player, who we know has a radius, or a diameter rather, of 1. So I'm going to set it to 0.5 in all directions. I'm also going to turn off use gravity. And, oh yeah, I guess that's part of the issue. Maybe I should turn off the mesh renderer, because the camera has been disabled because of that. I'll tell you what I'll do. I will re-enable the player here, and I will move this cube up to 2 so that we can more easily see the cube. Now in relation to the player, that's actually not too bad. Now, generally you want these guys to have different colors so that they're easier to notice, and that means we get to look at materials. Those of you who have messed around with 3D renderers are probably pretty familiar with materials. What we need to do is right-click on our materials folder and create a new material with the context menu. And basically the idea is, like, this is a generalization of textures. Materials basically tell you how to paint the cube. So I'm going to call this pickup material. And why don't we make this guy red? We drag this guy onto the material here, or not onto the material, onto the, let me disable my lights, or let me just get rid of them completely, move them out of the way here. We can drag this material onto the light here, and you will see that it's solid red. However, that's because it's this diffuse material here. We can actually change it to a number of things. There's diffuse detail, self-illuminant. We'll make it just completely solid. You can make it out of bark, and you can put textures in. In particular, I'm going to use something called specular here, which makes it shining. And so what we can do there is, we can move around it, and now the cube is real shiny. Now, we want this pickup here, and let's just rename it that. We want this pickup to interact in a certain number of ways. First of all, we want to make this a trigger collider, which means that whenever our player hits it, it doesn't reflect off the cube and vice versa. It just stands there. We also want to make this kinematic so that no physics occurs whatsoever with it. Now we're going to add another script, and we will call this pickup controller, to be written in C#. I'm going to move that guy into our scripts folder for organization's sake, and then we will go here and we will mess with our script. Again, we could do fixed update here, and in particular we want to make it rotate because it's easier to see that way. So I'm going to use a couple of new keywords here. I'm going to say read only, or first I'm going to use const. I'm going to say float rotation bias is equal to 5.0. And then I'm going to use read only vector 3 rotation is equal to new vector 3 1 1 1 times rotation bias. And so basically what we're doing here is we've got ourselves, I guess you can't really call it a unit vector as such, because it's you know, it's not pointing in one axis, but you know, we've basically got this deal to where we've got this constant here called rotation bias, and we've decided to store another constant, a constant vector called rotation that gets scaled by this. Now, why on earth would we want to do this? Well, the reason is because the vector can't be calculated at compile time. You have to use read-only instead, and that makes it unreadable. Now all we have to do is go to transform, can use rotate, and we can say rotation bias here. And when we look at this thing, it should, well, assuming I put the suffix on this, it should rotate around the dill, around the around its current position. You know, speaking of which, you might be wondering, why did we make this guy on the player script public? Well, as it turns out, one of the nifty things we can do with this is we can change our speed and tweak it, figure out which speed works best for gameplay. Maybe we want to go a little bit faster, maybe we want to go a little bit slower. And I guess I should talk a little bit about visibility, just for the moment. You see, visibility basically determines who can see your methods and your fields. So if we go back to this player controller here, everybody can see the speed here. So Unity has license to treat it as a public property of player controller, and it can directly edit it. Now sometimes you don't want that, and we will see a case where this happens in the future. In that case, you would probably make it private, which means that only the class that is declared in can modify it. Now, I think it's worth pointing out that that's not necessarily so of only the instance to which it belongs to. I believe that other instances of the same class in C# can modify this. It is at least so in Java with private variables. But let's talk a little bit about inheritance, because that may not make too much sense outside of its scope. Imagine for a moment that you have a special kind of controller that is just for a generic monster. And so, like, you might have zombies and maybe ghosts and, you know, soldiers or whatever, all are, you know, enemies or whatever. And they can be controlled in a similar manner, but they act quite differently. For instance, zombies will try to gnaw at you, soldiers will try to shoot their guns at you, and ghosts will move around and go boo. Well, in that case, knowing that these guys have clearly different behaviors, but that they share some behaviors and they share some state, for instance, they probably have health, you can make these things private. And what that would mean, of course, is that you could not set up the player like you couldn't modify the health outside of the construction of the root object. So that's a bit of a bummer. But there's also another access modifier called protected, to where any subclass can access the that field or method that's marked protected, but nobody else. And so maybe I'll show you how to do that in another tutorial. For now, you need to know about public for sure and private, the difference between the two, and then maybe internal too. For internal, that becomes useful like if you have plugins for, maybe like if you want people to write mods for your games. That internal makes it to where like your code can directly access it, but code in another assembly will not be able to. So that's that. We need another method in here. But before I do that, well, actually I'll go ahead and do it. I'm going to say void on trigger enter. Now, I've actually been having trouble recording this, and I might get hum on this still, but the last time I tried to record it, I accidentally put on trigger enter. It is in fact on trigger enter. We are going to see our first instance of passing in a parameter, and that parameter is going to be a collider. We're going to call it other. Now, do you remember how we tagged our player with the player? You might have not known what the tag was for. In this case, we cannot tell between the player and any other collider in this case. So the tag will help us. What we'll say is if other.tag is equivalent to, that's this double equals here, if it's equal to player, again this is case sensitive, then we'll want to say destroy objects, game objects. This is a field in mono behavior which contains the hierarchy entry. And so let's go ahead. I think we've already saved this. Let us now prepare this for something. What if we had to do this every single time? That would really be irritating, right? Well, Unity allows you to create something called prefab, so I'm going to create a folder for that, and I'm going to drop the pickup down there, and now our pickup is turned blue, indicating that it's a prefab. Now all we have to do is we'll give this an x of 2, and we'll drag up 3 more instances here. And what we can do there is now we can go on through, we'll make this guy basically go around in a counterclockwise motion here. It really doesn't matter where or how you place them, but now we can maybe go around and collect it. Let me go see what's wrong with this, because we are supposed to have the script attached. On trigger enter, we can do debugging on this. Maybe the first thing we can do is have ourselves print out the tag itself. And so this is useful in some ways if we want to go through here and see what's happening. So the problem is our player is untagged. I forgot to assign a tag to it. Maybe. It looks tagged to me. if we look at our console, we should have the tag attached to it. And that is rather annoying why it is that is not working in this way. I think what it is maybe is the camera is colliding with it. Is it this tag or the other tag? Oh, this is in the player controller. That's the source of our bug here. Now if we do this, if we play our game, we will see that we can in fact pick up these objects here, and they remove from the hierarchy, or they are removed from the hierarchy rather. So yeah, that's pretty nice. But really, for this to be a good game, we need to be able to do a couple of things, and this is where we diverge a little bit from the original tutorial that I'm redoing, the official tutorial, because the GUI engine has changed, as it turns out. In fact, one of my students at school told me that they changed in the middle of his development. He's working on a capstone project and happens to be using Unity. What we can do here is create an empty thing, and we'll call this game controller. Let's attach a script to it as well. And move that up to scripts. And if we go down to this guy now, we have a variety of things we can do here. The first of which being is that we need to know how many guys are in our deal here, how many items. So one thing that we can do is we can either have these guys send a message back, or we can attach a tag to them. Why don't we do that? We'll create a new tag here, and we'll call it pickup. Now we can go to this pickup here, set it as a pickup, and now everything is a pickup as well, which is really quite nice. Now I'm going to teach you about the for each loop here. Let's have private ints remaining, and remaining will be equal to 0 at the start. Remember, the start method gets called at the beginning of the scene when initialization happens. We could say for each game object in game objects, find game objects with tag pickup remaining plus plus, and then debug.log. We have remaining pickups to see the result of that. And if we are good for each game object G, rather, I'm just going to leave that like this. When we look through this now, we have 4 pickups. So we know how many we have and what we need to do to win the game, assuming that we can, we must collect them all. I'm just going to take this debugging statement out, however, because as it turns out, this is not very friendly to the user. The user won't be able to see the console. So what we'll do here is we will create a new UI object. Let's create a canvas. And this actually spreads out over the entire scene. If you see this 2D here, then we can go to the canvas. Why don't we add a text field as well. This new guy is pretty nifty in the sense that if we go to the text here, and for some reason it's not zooming out, just let me make that happen real quick. You can see our scene is really small. Now we want to go up here and maybe change this to score, or pickups left rather. And maybe make it to where the user can see this. Now this guy will be in the center of the screen, which is not generally what we want. So instead what we'll do is we will click on this guy here, hold down Control, or I think it's Alt and Shift maybe. Control and Alt. We'll pick this guy up here in the corner. And now this guy is up here, but nobody's talking. So how do we fix that? Well, we need to modify our game controller code just very slightly. So I'm going to import a new namespace. I'm going to say using Unity Engine.UI, and I'm going to create a public text score display. Now remember how I was telling you that we could use these public variables in the Unity editor to maintain the still, well, not to maintain, but to edit various objects. Well, what we can say now is we go up to this player and look, or not the player, but the game controller, and we look under that script. We have a score display, and we can drag the score counter over here, and all of a sudden these guys are linked up. Let's write a private method real quick to update this, called update score. And what we'll say is score display dot text is equal to pickups remaining, and then the remaining, and at the start here we'll call update score. We could update it in the for each loop, but because it's going to be the same anyway, then we will have this guy here. And now it should say that our score is equal to 4, which is quite nice for us. Now we just have to find a way for this guy to talk. So we're going to make this guy a tag it game controller real quick, and we're going to go back to that script. We're going to use something called, actually we won't use a static method here. We could use a static method. That basically means that the method belongs to the class and not an instance of the class. But we're going to just create a public method here. And we're going to say public void collects. And in that we'll say score remaining plus plus, or score or remaining rather, remaining minus minus to decrement it, and we'll say if remaining is less than or equal to 0, we will restart the scene, and the way we can do that is application load level then I believe application level or loaded level by the way, it's good practice to put comments in. There are two kinds. There's a single line comment, which you can see with the 2 forward slashes, and there's the multi-line comment, which begins with a slash and an asterisk and ends when it sees an asterisk and then a slash. So we'll say reset the level else update score. Now we can go back to our pickup controller here, and we really need two things. We need we'll have a private game controller, a GC. We'll go here to start, and we'll just say grab the game controller instance. So this will grab the first one it'll find. You have to be careful not to grab the wrong one. So we'll say GC is equal to game object find object with tag game controller, and then we can say get component, and then we're going to make this a generic statement. We're going to pass in game controller as the class, and we'll have that. It's a lot easier to do it when you're initializing the object because of the fact that it's looking this up is a little bit expensive, so you generally want to cache this. So we're going to say GC GC collect, and that will destroy our game object here. And when we collect all of these objects, you should see the score going down very slightly, and then when we collect this last guy, it resets the level. There's really only one more thing for us to do, and that is for us to make sound, because sound is very nifty. Now I'm going to import an asset from another version of this game. If we go to where is it? I think it is maybe somewhere around here. Let me look for it real quick. Okay, we're back. As it turns out, by default, Unity puts this in public projects, or public documents, which is not very good. I'm going to import some music here, or the power-up sound. We can do music as well, actually. But the music, as it turns out, was created by, let me just import that music real quick. The music I created with MuseScore, and then the power-up was used with SFXR, I believe. If we go to the pickup prefab, we can now drag this guy onto here. And when this guy is collected, we want to do a couple of things. We don't want to play on awake, and just make sure I'm recording again. Nor do we want to loop. But for music, it's the other way around, right? We'll drop this music on the game controller here, and play on awake and loop here. Now, this guy, I believe there's a way to go through here, because a game object is not a 3D sound. We need to actually go up here and untick 3D sound, as well as for the power up. Not that it really matters in this case because the camera is following us. But what we can say now, when we go here, is when we collect this guy, we can say, I think it's audio, audio clip, maybe. It's an audio source. Is it play? Yeah, audio play. And now we have a game with music but no sound. And the reason there's no sound, in fact, is because there is an issue where there's a the audio player is getting destroyed. Let me just bring down the volume real quick to 25%. And with this pickup in particular, I'm going to bring that down to 50 so it doesn't blow your ears out. And so what we need to do instead here is we need to go to this code, and we could use the GC's audio source, and we can maybe play one shot here, audio, and let's see if that works. It wants a clip. Okay, so the way we could get around that, or let's just try it and see if it works. Ideally, yeah, there we go. So we've got sound in our game now. And that is pretty much the end of the tutorial. The main thing that was different from the official tutorial, as you can see, is the GUI. And that was the main thing I wanted to address, but getting a full game out is not a bad start either. So anyway, I want you to maybe think about what you could do with this. I've taught you a lot, and maybe do some creative things of your own. But until next time, this has been Thy Lord Root, and I will see you later.